Yeah, I'm starting. We have enough space, right? That's me. I'm a software developer for many years. I'm in the software development business for many years, in different roles. A programmer, an architect, project manager, even a manager of managers. I'm doing it for years, and I have to say I don't really like it. I mean, I don't really like what's happening. I don't like how our projects are being executed, what I see in the source code. I don't like the success rate of the projects. I don't like the situation in the industry in general, with my project specifically and the projects I see around. And I'm not alone. So I did some research about the situation, and this is what quite popular report in the industry says about what we have right now. So we have a big problem. So they say that we have the chaos, basically. We have a big problem in the industry. Our projects are not successful. And they even in this report, they even give some numbers about that. So this 94%, they say, I'm not sure how they got that numbers, but they probably did a huge survey of companies. So they say that 94%, almost all of software projects, restart at some point. So we start writing code, we do something, and then we realize that we wasted money and we wasted time, and we start from scratch, or we redo a lot of work. Like in the keynote this morning, it was mentioned, the example was given, like the project was outsourced to an outsourcer, and then they created something, and then they threw it away and started to create it from scratch. So probably that kind of an example falls into this category quite well. So we are in trouble. And they say that only 7% of all this trouble are actually caused by technical processes. So because of the problems and bugs in the software by itself, I mean technical issues and some technology mistakes, only 7% of these projects fail. The rest fail for other reasons. For management, for many other reasons. And I think that we fail in most cases because we lack the discipline, we lack the proper rules of management, we lack something around the technical, the code writing. And this graph kind of shows the way I understand the problem. So I think that when we start a project, we spend about this amount of time for actually writing code, for building something, for implementing features, for creating something. And then the rest of the time we spend for rewriting it. So we spend for improving that, for refactoring, for making changes, for moving features left and right, for modifying what we created in the beginning. And this amount of time is kind of smaller, and that amount of time is way bigger. And this is the point where we release the software to production or something. So we can say that the project is finished here, but we still maintain it. We still need a lot of time and resources and money and our time to support it. So I think that the problem is not about writing code. It's not about creating something the right way, but it's about the way we create it so that all of us and other people can support it in the future, can understand it in the future. That's what I think is way more important problem than creating it right. So instead of writing, we need to think about how we rewrite it. We need to code for the future. We don't need to code for now. We don't need to code for ourselves right now. We have to code for our future self. For people in the future, us, including us and other programmers and everybody else who will maintain it, who will rewrite it, not just write it. So that's why I say we need to code ahead, like we think ahead. We need to code ahead. We need to code forward, not code now. And having this all in mind, I created a Softrock Competition, an award. Maybe somebody of you heard about it. Who heard about it? Anything? Oh, that's good. So it's an announcement for you. So I created a competition for open source projects 2.5 years ago. Invited open source developers to submit their GitHub projects to me and my team and the group of programmers who work with me for review. And our idea is to evaluate the project, not just the code, but the project, but everything around that code. How these people develop that stuff, how they think forward, how they build everything, how disciplined they are in their development. And the best project gets about $4,000 every year. So it's an annual competition. You can submit too. So we just started 2 years ago, and we just gave an award a month ago. So you have like a year in front of you. You can submit every year, and every year we give a prize of $4,000. So in this year, 2 years ago, we had 169 projects submitted. This year we had 60 projects. We don't know about the future, but I can say that these projects were, most of them were kind of, you know, low quality, most of them, so people submitted without even thinking whether it's whether their projects are good enough for the competition or not. This year they submitted, the projects were of higher quality, much higher quality. We had less projects, but the quality were higher. And some of them resubmitted again. Today I will explain you the criteria which we apply to these projects. So how do we decide which one is good, which one is bad? So how do we make the decision who gets the money? And we have basically seven criteria, seven aspects of how we look at that project. And by these 7 criteria, we make a decision. And I'll give them to you. So maybe they will help you. If you apply them to your project and think how you develop that, then you will probably improve. The entire idea is about, again, making the code which is maintainable in the future. So it's not as much about how beautiful your stuff right now, how great you write the code now, but how easy it will be for us to understand what you wrote in a year, which will mean saving money, saving time, and actually survival of this project. So let's go. We have 7 steps. Step number 1, I'll explain problems, sins, like in the title of the presentation. So we have 7 sins, 7 typical problems in projects, which people keep making, and we just point there and say, hey, you have a problem here, here, and there, that's why you're not the winner. So the first one is untraceable changes. People make changes to the source code without discussing them, without writing down why these changes were made. So sometimes they sit together in the room, they discuss, okay, let's make these changes, let's rewrite this class, let's rewrite this functionality. They just put their changes to master branch, to GitHub, to Git repository, and that's it. So if you open the repository in a month or in a year, you absolutely don't know why these changes were made. This information is lost. They definitely discuss that. They definitely, they have some discussions, meeting, whatever, but in the repository, this information is lost, which means that in some time, we don't know what happened in the past, and we need to rewrite it. We need to rewrite the code again. That's why many projects will fail. So people don't have tickets. People don't have branches. People don't have pull requests. People make decisions, programmers, they make decisions outside of the code. So we have a code base, we have like repository, some ticketing system, and then they submit a project to us and we see like 50,000 lines of code and 7 tickets. So 7 discussions and 50,000 lines of code. That's strange. They made so many changes and they never discussed them where I can see how they made the decisions. They had like a few pull requests, a few tickets, and a huge code base. The chances that this code base will be thrown away is very high, probability. About 20% of projects I've seen, and I've seen about 200 projects so far, so about 20% of them only have more or less proper ticketing system. So they discuss stuff in tickets. I don't know about your projects, think about them. So how do you make decisions about changes? Do you just discuss together informally and then just go and write? Or you create some ticket, you explain the problem, you name the problem, then you make some comments, and then when you push your changes, you link your changes to the tickets, to the ticket where you discussed that. And then in the future, I can click there and I can get back to the discussion and understand why you made the changes. So only 20% of people actually do that. The rest of them, they just keep writing code. They stay in that writing mode instead of thinking ahead. They don't think what's going to happen in the future. They just write the stuff they write. What about you? Do you have tickets? You have tickets, right? Do you have pull requests? I mean, do you work in GitHub? That's the first question, probably. How many of you work in GitHub? Just about 20%. And you use pull requests, right? You have to. That's the point. You have to use pull requests. You have to train your developers yourself, first of all, to submit changes through pull requests. Even when developer is alone, when you're just writing yourself, it's just your code base and you don't need to discuss with anybody else. Still, I would recommend to use pull requests. This is your master branch, then you have an idea of what needs to be changed, you create a new branch, you make changes there, you create a ticket explaining why you're making these changes, you link this stuff together, then you push to the branch, then you create a pull request, and then you merge your changes. This full path of submitting changes to the code base has to be there. It has to be visible for yourself in a month or in a year. Just 20% of people do that. The second problem is non-stop development. I call it non-stop development. We don't have milestones, we don't have releases, we just keep working, we just keep writing code. We keep changing, and we don't stop. We're continuously developing, which is continuous deployment, continuous delivery is a good thing. But continuous development, I think, is a bad thing. So we need to stop sometimes and make releases. We need to name versions. We need to call this is version 0.7. And then in a week, we have version 0.8. So we need to make these milestones, we need to package everything, we need to release, and we do it frequently. So we don't wait, we don't just version number 1, and then next year we have version number 2. We need to make micro versions. We need to break down our long development journey into micro steps, as small as possible. Like every few days, release of a new version with an upgrade, it's a good practice. About 10% of all projects I've seen, out of 200 projects, about 20 of them actually do that regularly. So they have that release. They stop and they package everything, they document, and they say, we just made this amount of changes. They write release notes. How many of you write release notes? Can you raise your hand? 1, 2, 3, 4, 5, 6, about 10 people. That's exactly the percentage I'm saying here, more or less. So the rest of you just develop. We need to write the release notes. They're not just for marketing. You know what release notes are, right? So when you download the new application from Apple Store, there comes the release notes sometimes. They say, we made changes and then the list of changes. We ignore that and say accept and that's it. We don't pay attention to that in most cases, and it's not for us mostly, I think. It's for the development team most of all. Because when you get back to the project, in a year, you can see how everything happened. You can see why all these changes were made and what were released, and it's a discipline for the team. It structures the development. It puts the structure on us. Because we're lazy, and the developers, we're just chaotic and lazy. And that's why we have chaos in the industry, because it's us, it's the nature of development. I know, like I'm a developer myself. So that's why we need structure. We need to force this development with these release notes on ourselves. Step number 3, problem number. I'm going one by one, and then the next one is bigger the problem of the previous one. So if there's no traceable changes, like changes which you just make, I think it's one of the smallest problems, and then we're gonna go to bigger and bigger and bigger. All is 7 of them. Problem number 3 is no documentation. And I'm not talking about this huge PDF files for users explaining how to use the product. I'm talking about documentation for the code. I'm talking about explaining what it is we have in the code. And it's not just comments for functions and for methods and for classes. It's mostly we pay attention here for the way you document, the way you write your high-level documentation. Because when the class is not really documented properly, it's not that big of a problem, because the programmer who wants to modify your class will find out how to do that if it's just a problem of a class. A class is a class, it's 100 lines of code or 200 lines of code or even 1,000 lines of code. But it's still quite small scope of, I think you're smiling, so sometimes it's way more than 1,000 lines, no? Yeah, it should be less than 1,000 for sure. But a class is a class. The scope is pretty limited, so I can look at it if I'm a programmer, and I can spend some time. But if I look at the module of the software, and I don't know what the module is about, how much time will I spend to understand what it is for, how it works, and everything? So that's a bigger problem. I don't know, do you know what UML is? You probably do. So I haven't seen a single project which would show the architecture, which would show the design when we review it, show us, the reviewers, the design in UML diagrams. None of them. Which is a great language. It was invented to help us to demonstrate the design, right? So I'm supposed to be able to open your source code, to open your repository and look at the diagram and understand, okay, now I know you have 5 modules and they connect like this and that through this, APIs or endpoints, RESTful calls, whatever, but you have 5 blocks. And I want to go to block number 5, and then boom, the 4 blocks is not of a concern for me. I just go down, I dig deeper into the module number 4. And then I open that module, and then I see another diagram, which also explains me where to go. It doesn't happen. It's just code. So you open it, it's like 500 files, 500 Ruby files, you just look at them, and you're trying to find out what's going on here. Like, sometimes people break them down into directories, folders in the file system, sometimes, well, in most cases. But by just looking at the names of these folders, you're trying to understand what's going on. So there has to be some documentation. That's my point. There has to be some explanation, some words explaining where to go, explaining what the structure of the code is. It doesn't happen. I don't know the percentage here. Well, actually, the percentage is 0. So I haven't seen any good documentation in any of these 200 projects we reviewed. It just doesn't happen. People don't write it. And I think it's not about the problem with writing, because, it's not so difficult to write it. The problem with updating. So we know it's easy to, more or less easy to look at the code when you work right now, to explain how it works, and then put it there and forget it. But how to keep it up to date? Because we change the structure of code. We move these modules left and right. We just, we toss them around. So we need to find a mechanism, which I'm not gonna propose the way you should do it. I don't know how, actually. But every team has to invent the mechanism of updating the documentation. And no projects, which I've seen so far, have this mechanism. That's a problem. I think it's quite big a problem. Also, use cases not explained. In all use cases, sometimes people explain. So we have the documentation which says, hey, to use our library, download it, do this and that, and then install it this way, and it will work for you. So these use cases people explain, like the highest level documentation for the end user. That happens, yeah. Open source libraries, they have that. But if you go into them without the creator of the library, you're in big trouble. And when we review projects, we don't talk to people. We let them submit their projects. They just fill a form and say, here's my project, take a look. But we never get back to them. We don't discuss and say, hey, can you explain us what's there, because I want to understand better. All I'm doing is just I'm opening the project, looking into it, and I'm trying to figure it out. If I can't, it's a failure. I just put it out of the list. It's not a winner. And we do it in 2 steps, sometimes in 3 steps. So first of all, there's many projects, like I said, about 100 sometimes. So I give it to a few programmers who work with me, and they go through all of them, spending like less than half an hour for each of them, trying to filter out like obvious crap. So we just filter out stuff which is not good for sure. And the way they do it is just, that's what I said, like they just open the source code, look at it, and just quickly just, hey, I don't understand what's going on here. I don't have this, I don't have that. Changes are not traceable, no documentation, no this, no that, just throw it away. So I get in my hands only about 10 projects out of a competition. So the big volume comes in, and then somebody helps me to filter them out, and then only 10 of them comes to me, and then I spend about an hour for each of them. So I'm trying to understand it better. But still, I'm not talking to the author. I'm not asking them, can you explain it to me? It's just me and the source code. And this is what happens in reality. That's why this rewriting is so important, because programmers, they change, projects and jobs. One programmer starts working on the project, and then he leaves or she leaves in a year. And then we have what? We have a huge piece of code which only one person knows how it works. And then we throw it away and rewrite. That's why we have this 94% of restarts, I guess. Am I close? Do you have that problems? Do you understand what I'm talking about? Okay, good. Try to submit your project, you will see what's going to be the feedback. And we actually give quite detailed feedback. That's also quite interesting. So you can look at my blog. There are logs, the detailed explanation of the review for the previous year and for this year. So for each project, we give a quite short review, like what was wrong. And for the finalists, for the list of the best projects, like these 10 guys, 10 projects which were good enough for me to review, I put a detailed overview. So I explain what's wrong. Like, you missed that, you missed this, I didn't understand that, I didn't understand that. So I give detailed explanation of this, the best project selected. And then one of them I say, I think this one is the best. The first year it was 1 project. The second year it was 2, because I wasn't able to select the best one, so I decided to give money to 2 projects, like 2,000 here, 2,000 there. Because they were close, they were not perfect. If the first year it was 1 perfect project, I guess the programmer made it for the competition, so he spent like about a year creating. He knew about the competition, so he spent some time to create it in the right way, and he managed to do it, so he got the money. The second year, they're not so perfect, so it was like more or less 7 projects were more or less on the same level, and 2 of them were better. So we decided to split the money between 2 of them. Problem number 4, I guess, it's no test coverage. Do you know what test coverage is? You know. So you know what is no test coverage means, right? So in most cases it means no unit tests. It's just obvious. So people just don't write unit tests. Do I need to explain why unit tests are so important? I don't think I have to. So unit tests are so important, but people don't write it. Why? I don't know. Maybe because they don't have time, maybe because they don't have money, maybe because they have something else to do. But my opinion is that in most cases people don't write unit tests because they don't know how to do it. Because writing unit tests for a big code base, it's a task which is more complex than just writing code. So just coding is probably 20% of the problem. And 80% of the problem is to write code which is testable. So I'm sure, well, you have to understand what I'm talking about right now if you're writing code. So just writing code, putting classes together, putting objects together, functions if you're functional programmers, putting this stuff together, it's just 20% of the task. And then when you try to make it testable, when you try to make it actually, when you try to break dependencies, for example, when you try to isolate objects from objects, when you try to make this code, the bugs repeatable in your unit test, when you try to mock something, when you start using mocking frameworks, then it's a way bigger problem. When you try to create integration tests, then it's a whole different story. And it's not just a regular programmer who just got out of school can do. It's a way more complicated test. So I think in most cases people just don't know how to do it, they don't want to learn that, they just put pieces together, put it to production, it works, they celebrate and just walk away. That's a typical scenario. That's why I believe unit tests. So only in 7% of these projects I've seen, only 7% of them actually write unit tests and calculate code coverage. Well, more than 7% write unit tests, but only in 7% I've seen real test coverage calculation. So it's a number. Or it's not, in most cases it's not just a number, but some kind of a table which shows that the pass coverage is like that, the line coverage is like that. There's some different percentages, some complex tables. Do you know what I'm talking about? Have you seen these tables? There are many tools for that, for different languages, so they build that stuff. And only 7% of projects actually do that and show this number for the developer. Why it's so important for maintainability? Why this number is so important? The number by itself is not that important. What's important is the way the team thinks about unit testing. So if the number is in front of the team, and if you develop and you look at this number all the time, then you will be motivated, subconsciously, you'll be motivated to increase that number. You don't want to see that number go down and down and down. You produce more code and the coverage it was 50% and then it's 40% and it's 30% and it's 20%. You have to be a really bad programmer if you will tolerate that. You will just look at it and say, who cares? 20, 10, I don't care, just put the code to production. So you will look at that number and you will want to improve that. You will be, it's just naturally that you will look at you will want to go to raise that number up. Only 7% of projects actually do that, and that's sad. And I think this test coverage this collection of test coverage has to be kind of mandatory, which nobody does actually. So what I mean by mandatory, I mean that in an ideal world, when you have your code, you automate your build. That's the first step. You know what build automation is, right? So you use some build automation, so you automate the build, and you put the coverage control into your build automation. So everything is built, compiled, packaged, and then you run coverage control, which says now the coverage is 75%. And the threshold, so the target is 80%. And now we have 75. So the build breaks. The build says, no, we just made some mistake because the coverage went down. It's like with unit testing. So you know that if the unit test is broken, then the build is broken. The same has to happen with the test coverage. If the test coverage is below the threshold, below the number we're aiming for, then the build is failed. The build fails. It doesn't happen. I've seen no projects which are, maybe I'm a little bit wrong, well, I think yes, I think I'm right, just zero, none. I haven't seen anybody doing that. So in all cases, people collect coverage, this 7%, they collect this coverage information, they publish this number, but if the coverage goes down, nobody cares, basically. So they keep writing code. Nothing will fail, which is not really good. Problem number 7. No static analysis. Who knows what static analysis is? About, geez, it's like 10%. Are you sure? Okay, I'll explain you what static analysis is. So static analysis is the way to check the quality of your code by running some tools. There are some static analyzers who look at your source code and they tell you where, in which lines or in which files you break the rules of a good quality coding. For example, just a simple static analysis rule. Let's say you say, I don't want to have names of functions or names of methods longer than 40 characters. So I don't want long function names, for example. They will work. If you create a function with a name of 60 characters, it will compile, right? It will compile, everything will work, no problem. But the static analyzer will look at your code and say, hey, there's something wrong, it's too long method name, for example. Or you may say, I don't want to have classes with over 10 methods or 20 methods. So if I have a class and there are 20 different methods in there, there's something is wrong. The design is wrong. So I made some mistakes. Even though it compiles, the Java or Ruby or whatever, any language, C++ will not complain about it because 20 methods or 200 methods or 2 million methods, it's perfectly all right for the compiler. But for the static analyzer, it's a problem. So static analyzer will complain, will raise a flag, and there will be many flags. So if you finish that, if you after today, go home and try to find a static analyzer for your language. For all languages they exist, even for Swift. I'm not sure about that, but probably they exist already. But for mainstream languages like C++, Java, Ruby, Python, PHP, JavaScript, they exist. There are many static analyzers. They're quite popular. So you download the analyzer, you ask the analyzer to analyze your source code, and you will see the amount of mistakes it will show you. The amount of red flags for the bad coding practices. So who write in Java here? Just about half. And the rest, what languages do you use? C#, JavaScript, Swift, use Swift, PHP. So for all these languages, you will find, I'm sure you will find a lot of mistakes, and there are not so many analyzers. So for each language, I would say there are like 2, 3 mainstream analyzers. So for Java, I know like 3 of them. For PHP, I know actually 1 of them. For JavaScript, I know JSLint, and probably that's it. So there are a few of them, but they are really helping you to improve your code, the quality of your code. And people use them. People use them in their projects, many of them. Many people use them, it's quite popular. But only 5%, or even less, they actually make it mandatory for the build success. So the ideal scenario is that you run your automated build through your continuous integration service or however, and then if any of these red flags are there, then you fail. So you have to develop your code the way that there are no red flags from static analyzers at all. And that means your code is clean. That means that you progress, you make more changes, you improve, that every time you stay compliant to the static analyzing rules. Just about 5% of people actually do that. The rest is just they get the huge reports from static analyzing software. They look at these reports once a month. They see, yeah, sure, that looks great, but we still want to continue the development. It's a funny story. I had this in this competition this year. I selected the best projects, like 7 of them, and then 2 projects won. And for one of them, for one of these losers, I mean not losers, but people who didn't win, I wrote a comment for one of them saying that there is no static analyzing there, static analysis, and published this whole thing, gave money, and just forget about this. And then the author of this project, of one of them, emailed me and said like, hey, you're wrong. We have static analysis. We have it there. Look at our repository. We use the software which which every day downloads our code from GitHub, analyzes, and shows us the report. And that's great. And I told them, look, I don't need that. I need a mandatory static analysis. So I want it to be built into your automated build. So you guys shouldn't continue developing your code if you just broke the rule of the static analysis. Because otherwise, if it's just a report somewhere, then you basically, you don't pay attention to it. You don't improve your quality by that. Well, you improve a little bit because you look at there and you just kind of understand what this static analysis wants from you, and then you maybe in the future you will improve a little bit. But this is not what the quality is about. You're not making your software better if you do it that way. And he said like, no, it's a huge email. I can't show you it here, but it was a huge email. He was trying to convince me like, no, you got it wrong. We are flexible. It's a flexibility. Sometimes these rules, some ideas from static analysis are right. Sometimes they're wrong. So we just look at them and we are being flexible in deciding what's the right way to go. So my understanding is this is the wrong approach, because being flexible here means low quality. If you're flexible with quality, if you're not strict enough, you're not rigid enough with your quality rules, then the quality just goes down. Okay, of course it's comfortable for programmers, for us. Like, sure, yeah, I write it this way. I have 10 methods in my class, and I put the method number 11. Yes, the static analysis starts to complain, but it works. So I push it there, and I finished. I'm done. I close my task. Yeah, sure, I kind of, one extra red flag is there, but who cares? There are like 1,500 flags already. There's going to be one more. But if there are 0 flags at the moment, and then I introduce new red flag, and the build says stop, we can't merge your stuff, it doesn't work, then it's a different story. I'm jumping to the next one. I'm not going to say anything about continuous integration, build automation. They're like obvious stuff, so I don't think we need to mention that. It's just a normal practice right now. So if your project doesn't have continuous integration, if your project doesn't have build automation, so you're just 20 years behind. So there's no point. I'm not going to say anything about that. There's somebody who doesn't have build automation? I don't think so. So you must have build automation. You have to build and package your stuff automatically, and you have to have continuous integration server who does it on every commit. So it's like saying that you have to keep your source code in some repository, in Git or Subversion or somewhere. So I'm sure you're doing that, right? You're not keeping them in files on your computer and sending to each other through Dropbox, right? So you have to use Git or something. Well, I would say Git. We have 2 more. The problem number 6, ad hoc releases, I would say. So actually about 2% of people use that, 2% of projects. What I mean here is that the question is, how do we get the source code together? How do we package it? And how do we put it to production or to some repository, to some Maven Central or NPM if it's JavaScript, or Ruby Gems, Ruby Gems, that's right. So how do we package everything and deploy it to where people can use it actually, to production platform or to some repository? In all projects, it's done somehow using some release.sh, some kind of a script or a combination of scripts written by authors of the product. So they know somehow to package it. There are some tricks, there are some secrets. Sometimes there's no script, they just know how to click here and there. They know how to go to Eclipse and say compile and package, and then there's jar file, and they FTP it somewhere. Boom, it's done. So this process has to be automated, and more, it has to be in the repository. So if this guy or a girl who is responsible for this release process is gone, I don't know, change the company, change the project, we still can do the same by just one click. So I should be able to step into the project, get the source code from the repository, and then click one button, and it goes to production. This is the goal which we all have to achieve in all projects. I'm sure, well, I guess, raise your hand if you have that. Wow, that's actually great, because I was expecting less. So that's great. If you really have that, if you really have this script which does everything without any necessity to call you on the phone and ask you how this script actually has to be executed, then it's perfect. Then you're in that 2%. But in my experience, when I open the project, always the question like, can you tell me how you release that? So you have releases. I see, yes, release like version 5.2, 5.3, 5.4. But how do you do that? How can I do 5.5 right now? And it's, in most cases, it's like, yeah, we just do it locally. Well, they don't answer me because I don't ask them, but I understand what's going on. Because there's no sign of this code in the repository. And it's super important. It's super important. I think that the project, which does not have this automated pipeline from the source code to production, and it's just a collection of files. It's just a big block of text files. That's it. It's not a software. If these files, if we don't have this pipeline from source code to production, it's just files. Because without this pipeline is way more important than the software by itself. Because if we have this pipeline and it's automated and there's unit tests there and there's static analysis there and there's code coverage control, then we have a package which actually protects itself. So if we lose the team, if we lose the understanding of what it is, if we lose the context, we lose a lot, and then we can still look at it and change a little bit here, change a little bit there, and the product will control it, will help us, will protect itself against, against damage. Because it will be very difficult for us to damage it, because every time we change a little bit, we'll click the button and try to deploy the whole thing. And it will break if we break something. And that's the point. Because otherwise, when you open the project, which you didn't work before, you open it, it's 1,000 files, you try to make a fix, and then okay, did I fix something? Did I break something else? You don't know. And it takes a lot of time, it takes months to understand how this whole thing works. But it shouldn't be like that. It should be like I open the project which I never worked with before, and I make a few changes, I click the button, and it breaks. Cool, it's great, because I know that I broke something, and I feel comfortable making changes, because I know that the product protects itself. So this release automation is the final step in protecting itself. It's not just only build automation, it's release automation. It's way bigger than build automation. So build automation is for your laptop. So you download the code, you build it locally, it fails, it breaks, or it succeeds, but it's just one step. But the full step is the full pipeline from building, packaging, then connecting to production, I don't know how, and then deploying it there and making sure we actually deployed it there, and then saying, okay, now it's a package. It's software. It's not files, it's actually a software. The final one, the biggest one, anti-patterns. Well, here I'm not going to say a lot here, but I'm trying to review object-oriented software. So all the objects, all the projects that people submit to the competition, they are object-oriented. And in object-oriented, I think the biggest problem, from the code side, now we're talking about code side. The previous discussion was more about DevOps, discipline, rules around the software. This is about the software. So of course, if the software, we pay attention to this a lot. So if the software by itself, designed with a lot of anti-patterns, for example, like singletons, which I think is an anti-pattern in object-oriented programming, or utility classes, or this anamic model, like objects without any functionality, and there are many other things which are anti-patterns, then the code becomes unmaintainable. It's difficult for new programmers to understand it, to modify it, to maintain it. All of these anti-patterns, they affect maintainability. They make the code less understandable, more difficult to read, more difficult to maintain, more difficult to improve. So when I'm looking at the code, remember the diagram I showed before, when the writing is small and rewriting is huge. So the anti-patterns making rewriting more expensive. If you write the code the way you want it, without even paying attention to the good practices of writing code, then the rewriting will be more expensive. And the chances of failure will be there. So we almost never fail at the phase of writing. We fail at rewriting. That's what I understand. That's what I think. When we write, it's always it's a bright work. We're so happy about it. We just work, we just develop. It takes like a month, and then we start rewriting. And then that's when we fail. So we need to think about that. We need to think about the future and avoid anti-patterns. I'm finishing. So this is my last slide. So my point is, point number one, I'm writing a book right now, which is called Code Ahead. So I decided to choose this name, Code Ahead, which means we need to stop coding for now, we need to start coding ahead for the future, which is way more important than writing code right. It's about the writing code for people to understand. The second point, maybe we're filming this, maybe if you want to sponsor this competition, so come back, I'm not sure, well, I'm just throwing it. So if somebody wants to sponsor it, to give more money so we can give that money to people who actually appreciate quality, people who write code in the right way. And what's important in the competition is that we don't pay attention to whether the project and the product is popular or not. We don't pay attention to what it does. So we only pay attention to how it's developed. So people submit code to us, even though there are some big projects in the competition, some big, for example, do you know CheckStyle for Java? So CheckStyle was in the competition for 2 years. So they also submit. So there are some big projects, come to the competition and they submit. And there are some small ones. So the winner, the first year, the winner was like, nobody knew about that project. In this year, there's 2 projects they won, and they're quite more or less popular in GitHub, more or less, but not like super popular. So we don't pay attention to popularity. We don't pay attention to how good you are in the market, how many people use you. All we pay attention is how much attention you pay for the quality. So that's why I'm asking, if somebody wants to sponsor, to give more money, so the price will go up. Now it's $4,000, it could be, I don't know, $15,000 or more and more. That will attract even more people, and they will start, paying more attention to quality. And the point number 3 is submit your project. Submit your project. It's open now. Check my blog. Send us your project. It's free. You don't pay anything for that. You just submit. And what you will get back, the minimum thing you will get back, is the feedback. You will get some information from us, pointing you to the right direction. We will tell you what's wrong in your project. That's it. I'm done. I guess we're out of time. Yeah? So thank you very much. You can come back and ask me questions later.